Preventing circuit overload. Knowing how amps, volts, and watts interrelate can help you prevent the dangerous condition known as circuit overload. When a circuit breaker trips or a fuse blows, it means too much current is being drawn on that circuit. You can calculate the current a circuit will draw simply by adding up the watts of all the lights and appliances being used on it at the same time. The wattage is stated on each of these items. Divide the total watts by 120 volts to get the amperage being drawn on that circuit. The resulting value should not exceed the amperage rating marked on the corresponding fuse or circuit breaker handle. For example, 1,800 watts is the maximum power that can be delivered by a 15 amp 120 volt circuit. 15 amps x 120 volts or 1,800 watts. Exceeding 1,800 watts will overload the circuit. Until that overload is relieved, the overcurrent protection device for that circuit will keep tripping or blowing, protecting you and your property. If you ignore these warnings and replace a blown fuse with one with a higher amperage rating than indicated for the circuit, you create potential conditions for overheating wires. Of course, this situation cannot occur in a house where the circuit breakers or fuses properly correspond to the wire sizes being used. Whichever overcurrent protection device you have would open the circuit long before there was any danger, warning you something was wrong. Don't ignore that warning. Just as a wire must be protected by a properly sized circuit breaker or fuse, the wire itself must be large enough to handle the load being served by that circuit. This point is crucial and is discussed in greater detail in the rough wiring chapter. Safety. That old saying, safety first, may be a cliche, but it's also true. Although electricity does marvelous work for us, under the wrong conditions it can be dangerous. You should not work with electricity unless you are prepared to treat it with the caution and respect it deserves. Use common sense and obey a few simple safety rules when you work with electricity. The most important rule is always shut off the electric power to the circuit on which you plan to work. Never attempt to touch wires or energized equipment before you kill the circuit. To make this disconnect, go to the service panel and flip the circuit breaker to off or unscrew the fuse that protects that circuit. Lock the box or leave a note to alert others that you are working on the circuit. Then, before you touch any wires, use a voltage tester to make sure it is off. If you don't have a voltage tester, turn on a light or appliance connected to the circuit before you make the disconnect. The light will go off when you shut down the circuit. As an added precaution, because you can't be too careful, tape the circuit breaker in the off position or take the fuse with you and post a sign on the box to warn others you are working on the circuit. Electricity and water do not mix. Never stand on a wet or damp floor when working with electricity. Put down dry boards or a rubber mat on which to stand while you work. Also, never work with electricity if you are wet. Change into dry clothes, including shoes, before you begin work. Never touch any plumbing pipes or fixtures, radiators, or metal ductwork while working with electricity. If you touch a hot wire and a water pipe, for example, an electric current could flow through your body. Never touch the wires supplying your service panel. They are still live even if you have pulled the main disconnect. Keep aluminum ladders away from these lines too. When your electrical work is completed, turn on the power and immediately check your work with a voltage tester. The tester should light when a connection is made between the hot wire and the grounded box. It should not light when a connection is made between the neutral wire and the grounded box. Use tools with rubber or plastic covered handles. Wear safety goggles or glasses and, when feasible, gloves. Use only one hand when working on service equipment such as a circuit breaker panel. Using two hands creates the risk of completing a circuit and having current flow through your body if you inadvertently touch a hot conductor. Perform all work in accordance with the National Electrical Code and local requirements, and obtain the proper permit from your local building department when required. Rules for using electricity. To use electric power safely in your home, follow these household safety tips. Never use a circuit breaker or fuse with an amperage rating higher than that specified for the circuit. Make it a practice to cover all unused receptacles so metal objects cannot accidentally be poked into the slots. Even better, install safety covers on all receptacles. To prevent fires, never run a lamp, appliance, or extension cord under a carpet or rug or through a doorway or other traffic lane where wear and tear can result in frayed insulation, exposing bare wires to flammable materials. Likewise, don't plug more watts into an extension cord than it is rated to handle. If you do, the resulting overheating will destroy the insulation in the cord, again exposing bare wires to flammable materials. To determine how much electricity an extension cord can safely support, multiply the amperage rating of the cord, 13 amps for a number 16 cord for instance, by 120 volts. The total is the number of watts the cord can handle safely. Then add up the total wattage of the items you want to plug into the cord. If that total exceeds the total permitted watts, something will have to be unplugged. Always unplug a lamp or appliance before attempting any To safely remove a power cord from a receptacle, grip the plug firmly with your thumb and forefinger and pull it out. Never yank a plug from a receptacle by pulling on the cord. When using an adapter for a three-pronged plug, be sure you properly ground it by connecting it to the screw that holds the wall plate to the receptacle. When you discover a cracked plug or a frayed cord, repair it immediately. Better yet, replace it with a new unit. Protect all bathroom and kitchen receptacles near the sink with a ground fault circuit interrupter, GFCI. All outdoor, garage, and basement receptacles should also be protected with a GFCI. The NEC requires GFCIs to be installed in these areas in new work. You can buy units that wire into regular receptacles in old work in order to provide this protection for your home. Install smoke detectors in your house and garage.